All right, this is section 12.3, day 1. And today we're going to do the surface area of pyramids and cones. And cones are truly just a pyramid with a circular base, and that will be the next lesson. So today we're just going to focus in on the pyramids part. So we want to talk about two different things in pyramids. We have a height and we have a slant height. So our true height is right up the middle of the base of the shape, right up to the apex of that pyramid. The slant height, you can kind of see they drew it in here. It's running along the outside edge or that outside triangle of the pyramid. So true height, plain height, is from the center up, and then slant height is actually on the outside of the shape. It's kind of running along the outside. What's nice is they actually make a right triangle for you, and you can bet that we're going to be doing some Pythagorean theorem again. All pyramids have this kind of basic shape for their net. The base is going to be whatever the shape of the base is, and then you have a triangle off of every single side. So those are your nets for a pyramid. So to the formula card, sorry, mine's already filled in, so I'm just going to cover some things up so you focus in on just our pyramids. We've got 3 different types for our pyramids. Sorry, one more thing. Cover up the volume so you don't copy those down yet. So we've got, our first one is just our triangular base pyramid. So first we have just the area of the bottom, which is a triangle. So 1/2 base and height, and then I write the triangle on the bottom so I don't forget. And then 1/2, and then it's perimeter of the bottom times the slant height. And the perimeter, remember, is just number of sides times side length. So you're just trying to figure out all of those triangles that are making up the net of this pyramid. So you can either write 1/2 PL, but you have to remember that P means perimeter of the base, or you can write 1/2 NSL. That's just another way to do it. N, remember, means number of sides. S means side length. And L, that cursive L, this right here, is this letter that we use for slant height. Next up, you have square bottom or rectangular bottom pyramids, and the bottom on those is just length times width, or base times height. That is how you find the area of a rectangle. And then you've got all the triangles around that side, or around that shape, that base. So you've still got 1/2 NSL. So same formula. This side is just all the triangles you're going to have, and then all you do is just change the front for what kind of base you have. So the last one is going to be that polygon bottom. So whether you have a hexagon or a pentagon, you're going to do 1/2 ANS, and then you're going to have all of the triangles that you have to add on after that. So the first half of the formula is what is the area of the base, whether it's a triangle, a rectangle, or an n-gon polygon. And then the rest of it is the 1/2 NSL, and that takes care of all of the triangles that are around your shape. All right, let's move all that. So just to reiterate, those formulas, they are the area of the base, whatever that happens to be, and then all of the triangles that are on your pyramid. So first one we've got here is, looks like my height. That's probably didn't copy well for you either, but it's pointing into that height. And then they've got the slant height out here with that cursive L. And then they're telling me that the base is 16. So I've got a base of a rectangle. So in order to do surface area, I'm going to do base of my rectangle, which is base times height or length times width. It's the same thing. And then I've got my triangles all around the outside. So 1/2 NSL. So base and height of my base, or my bottom, this is 16. And I know it doesn't say this, and I should have told you, but this is a square bottom. So if you only get one measurement, you can assume that that's a square on the bottom. So it's a 16 by 16. And then 1/2, N is the number of sides. We have 4. Side length, that's 16. And then slant height is the thing we don't know, so I'm just going to throw an L there. Well, I won't. I'll just leave it blank. So that's the slant height that we don't know right now, and we are trying to find surface area. So I need to know that so I can plug all of this together and find my surface area. So I'm going to take just this super light triangle that's sitting in there. So that's my true height. That's 15. And then that's my slant. That's what we're about to figure out. And then this bottom edge is actually half of the entire edge. So they're kind of pointing in there saying that is half of whatever your base is. So our base is 16, so that means that that bottom edge is an 8. And now we're going to be doing Pythagorean's theorem. So 15 squared plus 8 squared equals that slant height squared. So 15 squared plus 8 squared gives me 289, and don't forget to square root that, and so we get 17 for our slant height. And I'll throw 17 in there. And now I'm just plugging all this in, so 16 times 16 plus Instead of typing in a half, because every calculator does it just a little bit different, I would type in 0.5. That will eliminate any mistakes you might make with the parentheses around a 1/2. Some calculators need them and some don't. And then we got 736. Oh my gosh, that's a 17 and I wrote 15 there. You guys, 17. I was wondering why this felt a little off. Let's type that in again, shall we? Change that to a 17. There we go. 800. That's right. Let me white this out. Sorry. It's tough when I'm talking and looking all at the same time. Centimeters squared. There we go. So we solved for 17 and then somehow I talked my brain into writing down a 15. I think because I went and looked at that number instead. All right, next up, we've got another pyramid. This one is a triangular based pyramid. So surface area equals, I'm just looking at the formula on my formula sheet, which says we're going to do 1/2 base times height on the bottom, and then 1/2 NSL to find the rest. So my base and height on the bottom, if I'm just looking at that, looks like I've got a 15 for my base, and they're pointing at 13 for the height of that triangle down there. So this is what's on the bottom of my triangle. I've got a 15 right there, and then they're telling me that the height is 13. So that is my base and my height of the triangle on the bottom. Next up, I've got 1/2 NSL, so the number of sides is 3. The side length is 15. Again, we're going to assume that that's a regular, even though I didn't mark it because I should have marked it for you. So 15 on all the sides. And then our slant height, they're pointing right there, is a 10. So now this one I just get to plug into. So 0.5 times 15 times 13, and 0.5 times 3 times 15 times 10. So I got about 322.5 inches squared. Last one is one of those darn n-gon ones, so we're going to have to do 1/2 ANS. We usually end up having to do some kind of Pythagorean theorem in order to figure out the apothem. So let's set it up. So my formula for this, for the pyramid one on your formula card is the area of the bottom, so 1/2 ANS. And then you have all the triangles on the outside, so 1/2 NSL. So 1/2 ANS, I'm going to go over and look at my picture, see if I know the A. Oh, they gave it to me. 5√3, don't be intimidated by that. That's just a decimal we can type in our calculator. And then I've got number of sides, looks like 6. And then side length is 10, I got that right there. Plus 1/2 NSL. So N is still the number of sides, still 6. Side length is still 10. And then slant height, here's the picture of the pyramid. They actually gave me that too. So that was kind of nice. I don't even have to do Pythags this time. We're just going to get to plug everything in. So 1/2, and then you got a 5√3. Again, try not to be intimidated by that. It's just a decimal. Times 6 and times 10. And then we're going to add that to 1/2 times 6 times 10 times 14. Looks like we got about 679.81 feet squared. So those are your pyramids today. Start with the area of whatever the shape is on the bottom, whatever that base is, and then you have 1/2 NSL, number of sides, side length, and then that slant height, which is kind of on the outside of the shape.